What is up, guys? Mark here with the Rad Computers Computer Repair Stream. And today, finally, we're going to be doing something a little different. We're going to be making isopropyl alcohol. I have no music in the background just because I want to make sure that...
What is up, guys?
Ooh, hold on.
Here with the Rad Computers
Hey!
Computer Repair.
Sorry about that. I wanted to make sure that the audio does not get muted so that anybody that needs to know how to make the isopropyl alcohol can get it without me having to worry about whether or not the audio tracks that are playing in the background cause the stream to get muted. So all of the important information that I'm going to be providing is going to be readily accessible via the information here. So you have your source info, where to get it, why 60% or higher is recommended, how to do the math, and if you want to donate to the stream. So that is what we're going to be working on today. A couple of the tools that I have are a 500 milliliter graduated cylinder that I got from a chemical supply store. I have a temporary container in the form of a brand new measuring cup that does milliliters on one side. I'll also be discussing the difference between why you would want to use a graduated cylinder versus a standard kitchen measuring cup. I'll also be showing you how to mix it with basically a solo cup that has ridges on it. That way you can determine what you've got and how much you need to use. So we'll be going over that. I've got a pen and some paper so that we can do some calculations. I've got a kitchen scale so that we can do some measurements. But again, I will be showing you guys how to mix isopropyl alcohol in many different ways, not just from the measuring tools that you would have to go out and buy. So primarily the one thing that you're going to want to use is going to be either 99% isopropyl alcohol, which you get from a chemical supply store, or you're going to want to use 91% isopropyl alcohol, which you can get from usually a drugstore or pharmacy, a Walmart, convenience store, but in most places it seems like it's sold out right now. If you call a chemical supply store near you in your geographical area, you should be able to get 99.9% grade alcohol. So we actually have two. We're going to be using isopropyl alcohol here, and we're going to be using isopropyl alcohol here. So these are two different bottles. One of these is medical grade and the other one is semiconductor grade. The semiconductor grade alcohol is a higher purity than the medical grade, but the medical grade is by far a higher purity than what's called technical grade. Technical grade is not recommended or certified to be used for food, medicinal purposes, or drug administration. So you definitely don't want to try to sterilize something with technical grade alcohol. You want to get your grade as high as possible. So start with the medical grade at minimum, and then semiconductor grade is a little bit more expensive, but if you're in a situation where you need a lot of it, a lot of places will not let you buy only one bottle of a lot of places will not let you buy more than one bottle of the medical grade, so you got to buy semiconductor grade, which is a little bit more expensive. So they will both work for sterilization purposes. The purpose is to have the alcohol available, and then you need to dilute it down from 99.9% or 91% down to 70% roughly. You can do 71%. The CDC recommends doing 60% or higher. I'm going to do 70% because I've got so much of it, I don't really need to dilute it that much. But the difference between the dilution from 60%, 70%, 91% is that water acts as a catalyst in order to break apart the proteins so that it can denature whatever it is that you're trying to sterilize and disinfect. So if you go to our Twitch channel, we have a bot up right now. So if you go there and you type !60, it'll pop up with all of the information that is needed. I'm going to move this chat box up just a little bit. That way you guys can see that. Let me see here. Where is that page at? There it is. We're going to unlock that and we'll move it up here. Okay, so water acts as a catalyst. The 70% isopropyl alcohol solutions. I'm just going to read it. Penetrates the cell wall more completely, which permeates the entire cell, coagulates all proteins, and therefore the microorganism dies. Viruses are proteins in effect, so we are trying to break apart the protein molecule to prevent it from being an active agent in infection. So extra water content slows evaporation. Alcohol, 99.9% alcohol evaporates extremely fast. So it's not nearly as effective because if the alcohol is not on there long enough, then the process of breaking apart that protein or that microorganism takes longer than the alcohol can be there for it to actually occur. Having more water in the solution, so below 60%, reverses that process. So instead of the alcohol being effective, it's no longer effective because it's too diluted. So that's why the CDC recommends 60% or higher. As you start getting more and more alcohol concentration, that evaporation time starts to go down. So 99.9% grade alcohol evaporates really fast. 60% not so fast, 70% a little faster but still pretty strong, 91% much faster than 60%, but not quite as effective, primarily because it doesn't have the ability to stay on the surface as long, because once you apply it, it's already diluting, and that's the problem. So we're going to concentrate on making this concentrate down to a 70% solution using the tools that we have here. Alright, so now that we've gotten most of that out of the way, the math that we're going to use is as follows. So you take the amount of the solution that you have. So for example, this is 99% isopropyl alcohol. It's also called isopropanol or 2-propanol and IPA. So 99% IPA, which is isopropyl alcohol. The math would be the grade that you have, so 99% X as your variable equals, and then whatever you want to create. So if you want to create 0.6, then it would be 99 X equals 0.6, which is 60% in decimal format. You would then divide both sides by the grade, so you would take 0.99, which is 99%, and you would divide it by 0.99 on both sides. So then you would do 0.6 divided by 0.99, and your alcohol content that you add would need to be 60% of your total for whatever it is that you're going to be adding. So that may not make sense right now, but if you wanted to create 100 milliliters of isopropyl alcohol at 70% from 99%, then you would want to, and this is the 60% grade, then you'd want to fill it up to basically the 60 milliliter mark, and then from the 60 to the 40 with purified water or distilled water. That number would scale up, so if you want to do 500 milliliters, that's how much you want to create in total, then you want to do 60% of that, so you take 60% or 0.6, and you would multiply 500 by 0.6, and you would get, I know I can do this in my head, but 500, oops, that's 5,500 times 0.60, 60%, and you would get 300 milliliters. So if I wanted to fill this graduated cylinder up to the 500 mark with 60% isopropyl alcohol, then I would need to fill it up to the 300 mark using 99% isopropyl alcohol, and then from the 300 to the 500 with purified or distilled water. Lastly, if you wanted to make 70%, then again your math would change slightly. So you would multiply the 500 by 0.7, and you would get 350 milliliters, and then you would want to fill it up from 350 to 500 milliliters. In essence, that's what you're going to want to do. If you have 91% isopropyl alcohol and you're trying to make it stretch a little longer by diluting it down to 60%, then your math is roughly the same process, but you're going to get different numbers. So for example, let's just look at, let's just go to here. Alright, so here I am with my calculator. I'm going to make this a little bit less confusing for people by making the calculator cover up pretty much everything so that people aren't overwhelmed and inundated with extra extra data. All right, so here's the calculator. Our formula here is going to be our grade times x, equals whatever it is that we're trying to make. So if you want to make 0.6 to make a stretch or 60% IPA, then and you're starting with 91%, so that would be 91% times x equals 60% IPA. Well, you have to convert this into decimal format first. So your decimal format is going to be 0.91 and then x equals 0.6. So when we do the math for this, we'll just move this aside. So when we do the math for this, what we're going to do is we're going to do 0.6 divided by 0.91, and we're going to get 0.6593. So 0.6593. There's really no need to try to be more accurate than that. You'll never get the measurements correctly unless you have an insanely accurate scale or an insanely accurate graduated cylinder. So don't worry too much about going beyond that. Then we just convert this back to its percentage, and that is 65.93% in order to get 60% isopropyl alcohol. Now, back to our graduated cylinder here. Let's say we wanted to make 300 milliliters of isopropyl alcohol that was 60% isopropyl alcohol, and we're doing it from 91% because we want to try to make more than what we have on hand and make it slightly more effective because it'll be on the surface longer. So what you're going to do is you're going to do 300 milliliters, and you're going to multiply that by the number we just came up with, which is 6593. You're going to do that in decimal format, and we're going to get 300 times 0.6593. So we want to use 197.79 milliliters of isopropyl alcohol, and then when we subtract that from 300, we get 102.21 milliliters of distilled water or purified water. Hey, what's going on, Tesla? So in effect, that's what we're going to be doing today. Using that same example, let's say we want to take our 91% isopropyl alcohol and we want to make it into 70% isopropyl alcohol. This is what I'll be making today is 70%. So what you're going to do is you're going to convert this back into decimal format, just like that. And you divide both sides by the 0.91 in order to get x by itself. This is basic algebra. And you're going to divide 0.7 divided by 0.91. And you're going to get a content of 0.7692 as your alcohol content, or if you convert it back into decimals, then 76.92% is how much alcohol you're going to want to be using. So let's go back to our 300 milliliter amount. We're going to multiply that by 76.92%. This is using 91% grade, and we're going to get 76.92, 300, that's how much we want to have, times 0.7692. We're going to use 230 milliliters of of 91% isopropyl alcohol to get 70% isopropyl alcohol. And then of that, you're going to use roughly another 70 milliliters to top it up to the total 300 of purified water. That's how you get 300 milliliters of isopropyl alcohol. Now I've got 2 gallons here. It's really not necessary to have that much, but I know a lot of people that need it. I've got friends with kids. I've got friends with people with compromised immune systems. I've got older friends. People need it. So I've bought a ton of bottles. These are small bottles that I can hand out to people. Most of these will be filled with isopropyl alcohol. I've got some sprayers here. The sprayers will be used for making spritzers out of aloe vera. This thing hits so fast that we have no aloe vera gel available for purchase locally, so I have to use aloe vera juice. Now the difference between aloe vera gel and aloe vera juice is basically the same reason that you use water. So water slows down the evaporation. Aloe vera juice evaporates a lot faster than aloe vera gel does, and it doesn't moisturize your hands as much. A lot of people that have been washing their hands over and over and over again, they're winding up getting really dry hands because of the soap that they're using is drying out their skin. So aloe vera is used in hand sanitizers to try to prevent that skin dehydration, but the skin dehydration occurs because of the alcohol removing moisture from your body, from your skin surface as you go. So your skin starts getting irritated, you start getting bumps and mumps, and you get a rash. It gets really bad. So every time you do this, you're going to want to make sure that you try to add a little bit of moisturizer. Also got spraying bottles here. I bought a bunch of these so that people could start spraying surfaces down. And no, I'm not trying to profiteer from this. I'm literally going to be selling this basically at cost, plus the time it took to make this. So I might make 3% over what it would be sold for in store. I just want everybody to be able to get what they need, and that 3% will account for Venmo transaction cost. So that's basically how that's going to go. Hey, what's going on, Antoine? Thanks for tuning in to this very important stream today. I think I've pretty much explained everything that we're going to do, so let's go ahead and get to it so that we can do it. All right. So I've got my equipment here. My camera's turned a little bit. I'm not used to it being at that angle. What I'll probably do here in a minute is we'll do it a couple of ways first. So I've already got some water here inside of one of my 2 measuring cups. I've got it here primarily because I don't want to have to keep going over to my water source. But I do want to show you guys how you can do this first. So the most accurate way, in my opinion, is to do this by weight, and you need a scale that can measure in grams. So what you have to do is you're going to take your graduated cylinder, or your measuring cup, or whatever it is that you're putting on here, and we're going to weigh this. Okay, so the weight is what we're going to be going by. So all right, let's do this. Let me just change the angle of this real quick so that you guys can see. That's the reflection of my ring light right here, so I apologize. All right, so we've got isopropyl alcohol. Oh, I've also got a funnel here, for the graduated cylinder and then putting stuff into smaller containers. A funnel definitely helps, but if you're making it for yourself, you might not need to separate it into other containers. Okay, so first of all, what we'll do is we'll show you what the scale does in measurement. So right now the scale is actually measuring everything in ounces. You can see the little OZ right there. So this graduated cylinder by itself weighs 5.55 ounces. We actually want to change this to grams, because grams is going to be a lot more accurate. So this weighs 157 grams, the graduated cylinder does by itself. We're going to hit ZT or tare, depending on what kind of scale you have, and now it's at 0. So it's expecting us to fill up. It's going to be only weighing the liquid that we put into it. All right, so what we're going to do, oh, hold on. We can't do that yet, because once we add the funnel, now the funnel weighs 23 grams as well. I'm going to keep the funnel in here, so we're just going to keep that funnel there, and we're going to hit the ZT key again to zero it out, or to tare the scale. And let's just start with 300 milliliters. So again, we're using 99% alcohol, so we're going to do 99x equals 0.7, because that's the grade that I'm making. I'm going to be making 70%. And so we need to divide both sides by 0.99 to get x by itself equals 0.7 divided by 0.99. And we're going to throw this into a calculator. Not that I need to, it's basically the same as 7. And I'm pretty sure the math comes out to x equals 0.7007007 repeating. Or if you just move the decimal place over 2 points, then x equals 70.07%. So if I want to make 300 milliliters, I'm going to take this number, this is how much I need to use, and I'm going to convert it back into decimal format, which is basically 0.7, and I'm going to multiply it. So now I know that I need to do 210 milliliters, okay? So 210 milliliters of my solution is going to be 99% isopropyl alcohol. And then I need to take the 300 and I'm going to subtract the 210 and I'm going to get 90 milliliters of water. Okay, now my scale just decided to go to sleep. That's fine. Now we know the math and now we're going to apply it to the science. Alright, so hey, what's going up? Don't drink and drive, bro. So now what we're going to do is we're going to switch this back over to grams. I'm just going to show you guys how the measurements work out. So I've got the isopropyl alcohol here. I'm just going to start pouring it very slowly into my graduated cylinder until I get to this number, which is 210. Hey, thank you so much for the follow. Much appreciated. So that is showing, so the 200 line is here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines until 250. So if we do 250 minus 200, we get 50. There's 10 lines, so we divide those by 10. So then you get 5 divided by 1. So each line so each line equals 5 milliliters. So we need to go up to, let's see here, where are we going? We're going to 210, so we're basically at 210 right now, okay? Now, this is in the graduated cylinder. We have 164 grams of 99% isopropyl alcohol. We don't know how much we're going to be making, but I'll explain this math here in a second. So right now you can see the graduated cylinder is filled up. Let me get Mike's info out of the way. Nobody wants to call Mike. Alright, so you can see we are now here at the 210 mark, in between 200 and 250. We're trying to get to 300, so we're going to fill up from here to here with purified water, basically. Okay, and then after that, we're going to let it sit. Shake it up, do whatever. Now when you're pouring into a graduated cylinder, you got to pour slow because it's a very narrow shaft. I mean, it's a cylinder after all. And it'll fill up much quicker than you think you're pouring out of the container. Alright, so now we are at 300 isopropyl alcohol. Alright, I'm sorry, 300 milliliters of 70% isopropyl alcohol. We diluted it from here to here, and as we poured water in, it became less and less concentrated. All right, now there's a meniscus right here. It's a little bit under the 300 mark, which means it's more like 71% instead of 70%. So there we go. Now it's a little under. Now it's more like 60. Well, no. So the meniscus is right at the 300, so that's probably right around 70%. All right. I'm doing chemistry stuff for showing people how to make isopropyl alcohol. It's a very good question. Thank you so much for being here. Yeah, don't use too much alcohol for washing your hands. It can be counterproductive. It will dry your skin out. You're not going to have a very good time at all. So now we can just take this solution and we'll pour it into here, and this, when measured in milliliters, should show us 300 also. Now what we're going to do is just pour, pour, pour. All right. Now here is the reason why I recommend using a graduated cylinder instead of a measuring cup. So the measuring cup is less accurate. So looking at it, it says it's right at 300, sort of. You can kind of see it looks like it's higher up on one side than it is on the other side. But I guarantee you the measuring cup is less accurate than the graduated cylinder. Okay, so that's fine. Normally we would stir this using like a glass stir stick. I forgot to get one, so what we're going to do is we're going to take this 70% isopropyl alcohol mixture and we're going to go ahead and make our first bottle of spritzer. I don't know how much these hold. 10 ounces or 295 milliliters. So I guess we'll be doing this in batches of 300. All right, so I'm going to take my funnel. Trying to get all the water off of it. And I'm just going to pour this into this container. Hey, it took it all. Awesome. It's got a little bit left, a little bit of space up there for the straw. All right, now I'm going to tell you this right off the bat. Anytime, hey, what's going on, Adam? Anytime you guys make a chemical, it is extremely important to label what that chemical is. And you want to do it in permanent marker, and you want to do it several times around the bottle just to make sure that it gets seen everywhere. So this is roughly 70% isopropyl alcohol. I'm going to do it on both sides. 70%. This little squiggly is an approximation symbol. It's used for math and science purposes. Isopropyl alcohol. Okay. So I showed you guys one method of making isopropyl alcohol. Okay. Now I know you're probably thinking, dude, I don't know where to get a graduated cylinder from, like, or I can't afford the graduated cylinder. It's the alcohol, or it's nothing. I'm just gonna shake this up a little bit now. According to the websites that I've done the research on, it is recommended to let the isopropyl alcohol solution sit for 48 hours to neutralize any type of contaminants that are in here before you actually start using it. In my opinion, if you're using distilled or purified water and a mixture of 99.9% alcohol, I would say it's probably safe to say that using it immediately would be a better thing than to wait to try to desterilize something that might have COVID-19 SARS-2 CV on it, whatever. Okay, or SARS-CoV-2. It would be far better to sterilize something with your immediate solution that you've created than it would be to go, okay, well, I'm just going to wait 48 hours for this solution to permeate through and kill whatever minimal amount of contaminants I got from using purified or distilled water and isopropyl alcohol that I got from a chemical supply store. So feel free to use this right away if you feel like you need to sterilize something. So back to what I was saying earlier, I know a lot of you guys are going to be like, dude, there's no way, I don't have a graduated cylinder, I can't afford it, I could only afford the alcohol, what do I do? Well, now we're going to use a standard kitchen measuring cup. We're going to do the exact same thing, and we're going to make exactly 300. So we want to go up to 210. That's going to be slightly higher than the 200 here. Okay, and I'm just going to do this straight away. Slightly under 200. Just going to go a little bit more. Almost. All right. So it is right on the money. Now we're going to fill up the rest with our water. So we're going to go from roughly 210. Oh, you know what? It is supposed to be 210. We need a tiny bit more. Looks good. It's about 1/5 of the weight of the 250, so that would be 210. We're going to go to 300. Here, I'll get you guys a better angle on this. That way you can see what we're doing. Alright, so we're going to go to 300. I'm going to pour slow until I get to the 300. Yes, the table is at a slight angle, so I'm going to stop when it looks like it's crossing the center of that line. Okay, so that is an approximation of 70% isopropyl alcohol that you can make using 99.9% isopropyl alcohol, a little math, and a standard measuring cup. So now, let me put this into a container that we can use. This is the same size container as the last one, so it holds 297 milliliters. You can see that on the bottom here, or 295.74 milliliters. Focus, camera, come on. There you go. 295.74 milliliters. They lied. It does hold 300. All right, so we're going to take our funnel, put it right there, and we're going to fill it up. Now, it's interesting because these two bottles are exactly the same, right? So you'll see that the kitchen scale is less accurate, or not the kitchen scale, but the you're going to see that the kitchen measuring cup has less in it than another bottle the exact same size. So you can see, come on camera, stay up. This one does have slightly more than this bottle here. This is the one we made with the graduated cylinder. This is the one we made with the kitchen scale. Now, the difference in alcohol content when we're measuring that amount of volume, the margin of error is way better than if you were only trying to make 100 milliliters, where you have to be a lot more accurate to keep that ratio or that percentage correct. So now let's go ahead and we're going to label this. This is 70% isopropyl alcohol. 70% isopropyl alcohol. Now, for those of you that are like, well, what if I don't have a measuring cup, dude? I'm in college. The only thing I can do is go down to the chem lab or whatever, and everybody already took the graduated cylinders, or I can afford to get, you know, some 99% that my friend bought, but you know, he broke his graduated cylinder. What do I do? So here's where it gets interesting. All right, so we're gonna do this using a solo cup. All right, this is a dispensable solo cup. So what we're gonna do is we're going to mark a spot on the solo cup, and we're gonna mark it where, let's see here, let's just mark it right down here. Okay, so that's our line. All right, now that line is pretty low because we're gonna fill to that line 10 times. All right, because our ratio with 99% isopropyl alcohol is basically 7 to 3 to make 10. All right, so if we wanted to make 100 milliliters, we would fill it up to 70, and then we would fill the rest up with 3, and we'd have a 70% isopropyl alcohol mixture. So what we're going to do is we're actually going to take this and we're going to fill it up 7 times to the line, this line right here. We're going to fill it up 7 times with isopropyl alcohol, and then we're going to keep dumping it into a container, and then we're going to fill it up 3 times with purified water, and that's how you can make roughly 70% isopropyl alcohol. This is the least accurate way of the ways that we can do, but I'm going to show you guys this because in survival mode, you probably don't have a graduated cylinder with you. You probably won't have a measuring cup with you, but you might be able to find a container. If you can find a container and you can see through that container, you can use this method. So Zombie Survival Mode 101, here you go. Here's what we're going to do, and you have to make sure that you count this, all right? So I'm going to do this a little bit in the air just so I have a little bit better control over what I'm doing, because this cup weighs almost nothing. This is going to be the longest thing of my life. Here we go. You probably won't have a kitchen scale. Nope. I want it to be in that same line there. Yeah, having a marker during the apocalypse might be important, you know? Alright, that's perfect. So you can see that I've got it basically to the line. It's right at that ridge, so that's 1. Alright, we need to make sure that we count it because we don't want to lose track. So there's 1. Alright, I'm just going to use little sticky sticks. I've got 1 here. We're going to do hashes. So we're going to do 5, 2 more, and then 3. That's 7. I do 1, 2, 3, 4, and then a slash. Plus 2, that's 7. And then we're going to do a couple more. 3 more, okay? That's a little too much, so I'm going to pour it back in. I'm pouring it back in because it's just alcohol. If I had added any water to this, I would not put it back in my original source solution. Okay. Alright, so there's the second one. I'll just keep it over here. I'm going to mark it 2. As you can see, this method takes the longest, but in times of desperation, this may be all you've got. There's the third one. Mixing ratios like this is important to be able to know how to do. Because if you have to mix it in parts and you're on the run, when the zombies come, then sometimes you need to know how to do this. Alright, there's the fourth one. We got 3 more pours of this alcohol. Less. All right, that's the 5th one. So I've got my hashtag right there, or my hash. You know, it's like the prison sentence. Okay, I'm gonna do another one. Ideally, when you measure, if you're leveling it off, you want it to be on level ground. But that's, again, not always possible. Tiny bit more. All right. That's number 6. I'm glad I'm keeping track, because if I hadn't, I definitely would have forgotten which number that was. Now remember, you have to raise it to the same point every single time. If you do not raise it to the same point every single time, or let's say you run out before, you get there, like, oh dang, I can't even fill this up halfway now, then remove the line if possible, and then start your measuring over again with a shorter line, so that way you can try to get the ratio correct. All right, so there's the 7th one. Now these last 3 are going to be water. We're going to do it's easier to pour the water because it's coming out of a measuring cup, but there's a 1. There's 2. And this, you know, you don't have to be pouring from a measuring cup. If all you've got is a cup, it doesn't matter, so long as you've got a cup that you can mark and you can see clearly where it's coming through. All right, so there's 3. So this is a 7-to-3 mixture, which makes 10. That means it's 70% isopropyl alcohol, and it's 30% purified water. Okay, so now we can take that and we can put it in another bottle. Just out of curiosity, I want to see how much this is. That is 375 milliliters of isopropyl alcohol, so we'll have enough to fill up this bottle and then maybe one of those smaller containers. All right. So there's another one. Now this is plus or minus 70%. All right. It's literally like the margin of error on this. It's probably 65 or 75% isopropyl alcohol because of how we measured this particular bottle, but it still meets the CDC recommended guidelines of 60% or higher. Okay, so we're gonna just shake this up a little bit, and then we're gonna mark it again, roughly 70% isopropyl alcohol. We'll go ahead and do it on both sides. Roughly 70% isopropyl alcohol. Okay, now we have a little bit of solution left inside of our graduated cylinder here, so I'll just go ahead and fill up one of these tinies. Sometimes you need some on the go to like wipe a phone down or something. Ooh. So we did roughly 300, and these apparently hold, what, 25 milliliters? Okay, so this right here is roughly 70%. You guys are going to watch me write this a lot. It's important because if it looks like water and a kid's around and they don't know any better, they could just like open this up and go, oh, water, and then like drink it all. And then you've got a kid that has a really drunk attitude for the next, you know, however long. So, and you know, this is isopropyl alcohol. What if it's